Okay, this says given the geometric sequence where a1 is equal to 2 and r is equal to that complex number, find the 1999th term. So remember that a geometric sequence looks like this, right? You have your first term, and then it's the first term times r, first term r squared, okay? And so remember, like, this is a2, this is a3. Okay, in general, it's the first term r to the n minus 1. That's our nth term. And what we want is this term, so that must be a1 times r to the 1998, right? Because it's 1 less. All right, so like we know our first term is a 2. The question is, what is this r? What is this r to the, all right, what would that be to the 1998? So we'll take time to do that. This will bring in, you know, some ways of thinking of complex numbers that'll be helpful. Okay, so again, we know that we're looking for 2 times square root of 2 over 2 plus root 2 over 2i raised to this. Now, anytime you're trying to deal with complex numbers and you're multiplying or raising to a power, you want to change to polar form. So in polar form, okay, like here's my, you know, my first quadrant of the unit circle. Root 2 over 2 plus root 2 over 2i is precisely this right here. Okay, and so I can replace this with 1 CIS 45 degrees. So now I've turned it into one that's going to be more manageable, or a form that's more manageable. So now this is 2, and then this is like 1 to the 1998 if I use Demois' theorem, and then this is 45 degrees times 1998. Okay, we still not done. I gotta figure out what's going on here. Now we're not gonna sit here and multiply that out, but what we do notice is that, remember, so if I call my complex number, well, it's already called r, I guess. That's r. Remember, r squared would just move you another 45 degrees, and another r square, another copy of r would move you here. R to the 4th would bring you back to negative I. So the point is, I can tell now, right? I'm back here. I'll reset to 1 every time I've exponentiated to a multiple of 8. So the question is, like, how many multiples of 8 is 1998? So let's just go off to the side here. 1998, we want to know how many, you know, I'm going to divide 8 into that. So 8 goes into 19. Okay, so now I get, it's a 398, and then 8 goes into 398 4 times. And it goes into 78 9 times. Okay, so it turns out that I can rewrite this. I can rewrite that as 249 times 8 plus a remainder of 6. So now I got that this becomes 1 CIS 45 degrees times 249 times 8 plus 6. Okay, and then this is the key idea is if I distribute this and I multiply, because, you know, I'm going through, basically I'm just going to be rotating around the circle 249 times, which brings me right back to 1. Okay, and then I'm going to go an extra 6 times 45 degrees. So this is 2 CIS 45 degrees times 6, which is 2 CIS. Now 45 times 6, if you do that out, gives you 270 degrees. Okay, and if you can answer this, you know, at this point, you can either go to your diagram, 2 cis 270, just rotate 270, walk out 2, it's here at negative 2i. Okay, but if you want to unexpand this, remember this is just, you could also do it this way, right? 2 cosine of 270 plus I sine 270, which gives you 2 times 0 plus I times -1, which gives you -2I. Okay, so the answer is negative 2I. So that's an interesting question, right? And again, most of the thinking had to do with kind of figuring out essentially how many multiples of 8 are in 1998, and then whatever's left, that's how many rotations of 45 we get to.